Welcome to another activity. In class, we've been talking a lot about these gas law equations. We have the three basic ones that only involve two variables each: Boyle's law at constant temperature, Charles' law at constant pressure, and Gay-Lussac's law at constant volume. But as you know, in the real world, it's hard to keep things constant. That's where we have our combined gas law and the most important one, in my opinion, the ideal gas law, PV equals nRT, or as some of your teachers probably have called it, PIV-NERT. This explains how gases can work at a variety of different pressures, volumes, temperatures, and it accounts for moles. Now I know it's been a little bit since we talked about moles in calculations, since the moles in Stoic unit, but it's still really important, the amount of gas. Because based on the conditions, you can have a small or a large amount of gas that do things differently. Now, one thing that I want to make very clear as well in this lab, R is the ideal gas constant. And there are two values for R. 8.314 kPa and 0.08206 atm. Now, depending where your teacher is at in class, you might only be talking about 8.314, and you might not be talking about the conversion between atmosphere and kPa. The reason I'm mentioning this is because these are both equally important, and because they are different pressures, there are different R values. These don't need to be memorized, these would be given to you, but for the sake of this lab, and because I think the majority of the teachers are doing R and kPa, we are strictly going to be using 8.314, and you do not, for this lab, need to worry about 0.08206. I want to show you why I made that determination. One of the things that we need to know is the atmospheric pressure of gas in the room. Now, I'm going to be using half a tablet, one tablet, and actually, for you guys, we're going to do 2 tablets of Alka-Seltzer. But we need to really look at the atmospheric pressure of these things. So what you can do, I just went on literally weather.com and I found Aurora, Illinois, and the pressure is right here at 103 kPa. We're going to check this, and I'm going to update this because I see that it's 8:15 a.m. that this was last updated, and that was 15 minutes ago, over that. So we're going to update and make sure that we have the most up-to-date pressure, but because that is kPa, we're going to use 8.314 today. And there's going to be a few little twists and turns along the way.